this video, I'm going to go over weathering, erosion, and deposition, three terms that should look familiar because we talked about them when we discussed the rock cycle. Weathering is quite simply the breakdown of rocks at the Earth's surface. There are two primary types of weathering. The first and kind of simplest to understand is physical weathering, also referred to as mechanical weathering. And this just involves the breakdown of material into smaller pieces. There is no sort of chemical or compositional change here. So you can imagine just taking a sheet of paper and ripping it into smaller pieces. Each individual piece is still the same, chemically speaking, just smaller. Another good example, common example in earth science, especially around New York City and New York State, is known as freeze-thaw or frost wedging, where water gets into a pre-existing crack during the day. At night, that water can freeze. When water freezes, it expands, making the crack larger. This process repeats over and over, day after day, night after night, and that crack eventually gets so large that it can crack a significantly large boulder clean in half. The other type of weathering is a little bit more difficult to understand, and that is known as chemical weathering. It's still involving the breakdown of material into smaller pieces, but it's via chemical reactions. So you're actually changing the chemical composition of the material. You're destroying what minerals were there and you're creating new ones in their place. A very common example is rust. I'm sure you've seen rust on things like bike chains, like you see in the picture, cars, signs, fence posts, all sorts of things around kind of the human landscape. But this process also happens in rocks. Very often, students confuse weathering and erosion. They are very distinct processes, but they are related. Remember, weathering is the breakdown of material. Erosion is the movement or the transport of sediments from one place to another. In the picture, you can see the Grand Canyon. This is an excellent example of both weathering and erosion. So this beautiful canyon was carved out by the Colorado River. As the Colorado Plateau was uplifted, the river just flowed through the landscape and it was weathering and eroding. So it was breaking the material down as well as carrying that broken down sediment away from where it once laid. Some important agents of erosion, things that are moving material or sediment around, include water in the form of rivers and wave action, wind, ice in the form of glaciers, and gravity itself. Material can't move indefinitely. At some point, it will stop. And when it stops, we say that it has been deposited, or it's been laid down, it has settled. This is kind of the end of the weathering and erosion cycle. And so in the diagram, you can see weathering causes the breakdown of rocks on this hillside, and then erosion takes these broken down pieces and essentially moves them down the hill where they're deposited in the water. Both wind and water will sort sediments as they are deposited. So what does sorting mean? It just means that there's an arrangement based on size. An important thing to know is that water velocity decreases when a river enters a larger body of water, something like a lake or the ocean. And why is this important? Well, it's because larger sediments get deposited first. Why is this? It's because larger sediments require more energy to transport. When the water slows down, there's not enough energy to continue to carry them, so they get deposited. So that also means that smaller sediments are going to be carried farther into the lake, into the ocean. Right? And that is because they require less energy to transport. So what does this look like? This diagram nicely shows this. So we have river flow from the left-hand side towards the right side of the diagram. And if we're assuming we are carrying boulders, cobbles, pebbles, sand, silt, and clay-sized particles, the boulders will be deposited closest to the mouth of the stream where it enters the larger body of water, followed by the cobbles, pebbles, sand, silt, and clay. Turns out particle shape also has an effect on settling rate. And so between particle A and particle B, which one settles first? Turns out A is going to reach the bottom faster than B. Why is this? A is a little bit more sort of hydrodynamic or aerodynamic if it's falling through air, so it will not experience as much drag as B. If you don't believe me, try this with a sheet of paper. Have one sheet of paper, lay flat, and then take a piece of paper, crumple it into a ball, drop them both from the same height, and see what happens. You should notice that the flat sheet experiences kind of a drifting back and forth because it has a significant amount of surface area exposed. So there's a lot of friction or drag as it flows through the air. Same thing's going to happen in water. So our first practice problem. So again, it's always a good idea to identify what is the question asking and then what information is given. This question is asking for which sample and important information has traveled farthest down the river. And so we look at particles A, B, and C. First thing that comes to my mind is C is very, very round. Means it's going to have traveled farther down the river. So as it's moving down the river, it's not isolated, it's moving and hitting against other things, and it's going to slowly knock off any sort of sharp edges like you see in A. This will slowly get rounded over. So the correct answer is C, because as it is moving, as this sediment is being eroded, it is still weathering. And so things like abrasion are still acting on it, serving to round off the sediment. It turns out as sediments move downstream, they tend to get smaller in size and rounder in shape. Practice problem 2. Right, so we're looking for which event, and specifically which event is an example of erosion. So it's a good idea in this case to identify keywords in each answer choice. So answer choice 1, breaking apart. 2 is dissolving. 3 is rolling. 4 would be crumbling. These are what I deem as the kind of key phrases in each answer choice here. So breaking apart, dissolving, and crumbling all indicate the process of weathering. Things are getting broken into smaller pieces. 3 is the only example where something is moving. Rolling is a form of movement. So this is our example of erosion. Third and final practice problem, we have a stream that is entering into a lake, and we want to know which corner is closest to the point where the stream flows into the lake. So you have to think back to this idea of horizontal sorting. When water flows into a lake or an ocean, any larger body of water, it's going to slow down. And when water slows down, it's going to deposit the largest size particles that it's carrying before it deposits the smallest size particles. So we take a look at the diagram, and I notice that silt's in the northeast corner. There's sand and silt, sand, sand and pebbles. Silt is the smallest size particle here. Pebbles are the largest. So that tells me that this area is when the water first entered into this lake. So the stream must be somewhere in this bottom left-hand corner. So we're looking for the southwest corner. That's answer choice number 4. I hope you enjoyed this video. If you have any comments or suggestions, please leave them below.